And gentlemen, please have a seat. Now on, we move to our next agenda. We will invite to the stage the most responsible person for the conduction of this international skilled event, Dr. Emi Pratiwi, as a General of MASTIC 2020. Time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Selamat pagi. Honorable Professor Dr. Adi Suprayitno, Vice Rector 1 for Academic and Student Affairs of ITS. Honorable Professor Adi Maimun of University Technology Malaysia. Honorable Professor Sardarkum of Istanbul Technical University, Turkey. Honorable Professor Ketut Buddha Artana of ITS. Honorable Professor Masao Furuso of Kobe University, Honorable Dr. Trika Pitana, Dean of Faculty of Marine Technology ITS, Honorable Head of Marine Engineering of ITS, Honorable the Coordinators of Center of Excellence of Maritime Safety and Marine Installation, Dr. Dimas Widi Handani, and also all the authors, presenters, and participants of MASTIC 2020. It's my great pleasure to welcome Second Maritime Safety International Conference MASTIC 2020. I hope that all of you are in a good health during this tough situation due to the pandemic. The Second Maritime Safety International Conference 2020 was planned to be held in Bali. However, the COVID-19 pandemic, we decided to hold a webinar conference. MASTIC is the biennial conference organized by Marine Engineering Department of ITS, collaborated with the Center of Excellence Maritime Safety and Marine Installation Pui Kakao. On behalf of the MASTIC 2020 Committee, I would like to extend gratitude to all of the authors who contribute the submission of the result of their latest research. The committee of the MASTIC received 97 full paper submission. From those submitted paper, there are 81 papers that will be presented in MASTIC 2020 today. Also, I would like to express my grateful to the technical program committee and the reviewers for their support in the reviewing process to keep the quality of the manuscript. The committee received submission from 7 different countries. They are from Japan, Malaysia, South Korea, Indonesia, United Arab Emirates, and also United Kingdom. With the theme of responding to the future's technological challenges and opportunities in maritime towards safety operation at sea and environmental protection, MASTIC 2020 becomes a great opportunity for all the authors, researchers, students, and practitioners to participate in exchanging information and their latest research regarding the maritime safety. Today, in this event, we will have keynote session and also parallel session. There are three prominent keynote speakers to whom I would like to say thank you very much to their support to MASTIC 2020. They are Professor Dr. Adi Maimun from University Technology Malaysia, Professor Dr. Sedarkum from Istanbul Technical University, Turkey, and also Professor Dr. Ketut Buddha Artana from Institute Technologies 10 November, Indonesia. The three keynote speakers would like to deliver the research about the implementation of automatic identification system in their own countries. It will be very important topics since AIS research has been much developed in recent years to enhance and to improve the safety in the marine field. We would also appreciate it for IOP conference publisher, so we could make an agreement to publish the MASTIC proceeding to the IOP conference series, Earth and Environmental Science. Lastly, thank you very much for joining this webinar, Honorable Directorate General of Transportation, Distrik Navigasi Kelas 1 Surabaya, Distrik Navigasi Belawan, Bapak Abdul Aziz, I also would like to deliver warm greetings for our colleague Kobe University, Politeknik Perkapalan Negeri Surabaya, Politeknik Negeri Banyuwangi, Politeknik Negeri Madura, Universitas Mataram, and also our partnership university, BP Indonesia, PHEWMO, Pertamina, and also our other colleague that I can mention one by one. Currently, we initiated to have a joint research about AIS with these three university, Politeknik Negeri Madura, Universitas Mataram, and also Politeknik Negeri Banyuwangi. Hopefully, it will be strengthened our relationship among universities. Once again, thank you very much for your support. I wish that the aims of the MASTIC 2020 still can be achieved, so we cannot conduct the conference as usual. Hopefully, the next MASTIC in 2022 will be held in much better situation. Thank you very much for the participation and enjoy the conference.
Thank you, Dr. Emi, for the speech. And the next agenda is speech from Vice Rector 1 for Academic and Student Affairs of ITS. With an honor, we would like to invite Professor Adi Supriyanto as the Vice Rector 1 for Academic and Student Affairs of ITS. Also, in the end of the speech, we'll symbolize Open MASTIC 2020.
Okay. Thank you very much, everybody. Assalamualaikum warahmatullahi wabarakatuh. My distinguished guests, especially Professor Adi Maimun from University of Technology Malaysia, and also Professor Kedut Buddha Artana from ITS, and also Professor Sardar Kum from Istanbul Technical University, and all MASTIC 2020 participants, all MASTIC 2020 committees, ladies and gentlemen. First of all, it is a very good chance for me to warmly welcome all of you to this MASTIC 2020. Well, as mentioned before, actually this occasion will be held in Bali, but we know that now we still faced with COVID-19 pandemic, so we arrange this in webinar to ensure the seminar can be safely held. Okay, I also hope that this webinar could give you an overview of situation that positively contribute to all of us by exchanging good studies. Well, all of us know that as maritime countries, Indonesia has set maritime development as one of the top priorities in the country's development programs. Therefore, the issue of safety becomes one of the main issues, especially the safety of sea transportation and also the safety of the maritime industry. Many aspects that is related to the safety of transportation and maritime industry that do not only have impact on human safety, but will also have an impact on the environment, economy, fishing industries, maritime-based industries, and these impacts are likely to be felt in the long terms. Therefore, I strongly support the Maritime Safety and Technology International Conference as a medium for exchanging ideas, information, ideas, and working together in the effort of improve academic quality and increase contribution to the nation and states. So we don't want that we will stop only in the conference, of course, but we will go with in the future with the real work. That's to gain common welfare together. So I invite active participants from academic institutions, research institutions, government agencies, and also the maritime industry, the manufacturing industry, the shipping industry, etc., and all the stakeholders in the maritime transportation safety and the maritime industry to jointly succeed the MASTIC 2020. I would also appreciate the great effort of the organizers of MASTIC 2020 in preparing and executing the conference. I also advise that the results of the conference can be formally conveyed to the governments, especially the ministry institution related to the maritime. I wish a very nice experience for all participants. Please enjoy your discussions and stronger networks. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. But, let me open this ceremony by, in the name of the Almighty God. Bismillahirrahmanirrahim. In this very good mornings, I open this conference and hopefully this will, hopefully that this conference will can help fluently and we have a new advantage of this conference. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Adi, for the speech and officially open the MASTIC 2020. Ladies and gentlemen, since our event is an international scale event, we also looking at improving our collaborations and corporations among the countries. Our next agenda is appreciation ceremonial of outstanding contribution in initiation and collaboration between Kobe University and ITS. That's why, with an honor, I would like to invite Dr. Trikapitana as the Dean of Marine Technology to hand the appreciation.
Thank you very much, Lord Master of Ceremony. Okay, sit ya. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Distinguished professors, all of the professors, the vice rector ones, and distinguished professor, Professor Kum Serdars, Professor Ketut Buddha Artana, and Professor Adi Maimun. This is the time for giving some outstanding, outstanding token appreciation to any person. Is basically giving some outstanding contribution to to our university, especially for the ITS. I would like to give some a little bit story why it's considered as the outstanding contribution. When I was student at the time, 2007 in Kobe University, and Professor Saidar is my neighbor at the time, my neighbor laboratory, and my professor Kobayashi Sensei giving some idea also with Ishida Sensei and Kuruso Sensei, giving the idea how to utilize IIS data for a research. And it is I suppose that it is a very brilliant idea at the time. And many students in our laboratory, in my laboratory, especially in Kobe University, all PhD students from Indonesia, especially utilizing the AIS data and successfully graduated because of the AIS data. Then those data still also continue utilized to make a research. And my life site, for instance, is Dr. Amy also graduated because utilizing AI's data. So we can call that it is a very outstanding contribution from the Kobe University to ITS and several universities. And I was remember that we are installing some equipment in UTM, then in ITS as well, then in ITU, and making some working together to this end. In order to do that one, on behalf of the ITS and also Faculty of Marine Technology, and especially for Marine Engineering Department, then we would like to hand over as the token appreciation to Professor Masao Furuso. This is only the token appreciation. I believe it's not possible to replace your outstanding contribution. And the second one, we also hand over to Professor Kenji Isida, which was passed away 2000, 2000, I'm not sure, 12 or 11, sorry. 2011 was passed away. But the idea is coming from the Professor Kenji Isida. Then uh, until now, it's still going around that the research is still coming up. So so I cannot say that this is the great contribution from Kenji until now. And we call in Islam, it's called Amal Jariyah, probably. And Sodaqah Jariyah, that, because there is uh, some contribution and the data in the idea from Kenji that still using until now. And the third one is Professor Eiji Kobayashi. Kobayashi, so I call that Kobayashi. Say that it's also my supervisor. The Professor Kenji is that previously is the, the former supervisor is Professor. I suppose there is all the appreciation ceremonial of outstanding contribution in initiation and collaboration between Kobe University and ITS. Thank you very much. And I would like to invite Professor Furuso to giving some speech uh, relating to this contribution. Thank you very much. Professor Furuso, please.
Thank you very much. Good morning, everybody. This is Masao Furusho speaking, a professor at Graduate School of Maritime Sciences, Kobe University, Japan. It is my great pleasure to have the good certification. I would like to express my sincere congratulations on the opening ceremony of MASTIC 2020, which is holding the second time to be held by online today. This year, 2020, various events were cancelled due to the pandemic caused by the spread of coronavirus, forcing Japan to refrain from daily life. Recently, the increase in the number of infected people in the capital city, Tokyo, has become a new concern. Online lectures and conference meetings at home have become routine events. New students planning to enroll in April have no entrance ceremony, and the fact that online classes have started at home is the beginning of the new higher education. The first MASTIC 2018 was held 2 years ago in Bali Island, Indonesia. So I feel the spread of the time as 2 years have passed. By the way, this time the keynote speeches are organized under the theme of AIS, Automatic Identification System, and I'm looking forward to interesting talks of the keynote speakers. I am confident that the AIS Observation Network Development Project, which started as a joint program between the International Maritime Research Center of the Graduate School of Maritime Sciences, Kobe University, has brought out today's result through the dedication of researchers. Not only Japan and Indonesia, but also Malaysia and Turkey were able to obtain the participation and cooperation, and many researchers' results were announced. The topic of maritime safety will be of interest to autonomous ship, the problem of change of crew in port, and the operation of vessel that use liquefied natural gas or hydrogen as fuel. In addition, women's advancement is also a welcome topic, and we are welcoming new developments. Kobe University has been under construction of a new training ship and is scheduled to enter service next year. I hope that various studies on maritime will be further developed with the formation of a new framework for maritime education and research. We hope that this first attempt a web conference webinar has produced sufficient result, a remarkable successful result, and is fulfilling conference. 2 years later, the third MASTIC 2022 will be held in Bali, and we would like to extend our greeting in hope that we will all be able to see you. Thank you for your kind attention. Bon voyage. ありがとうございました。Terima kasih banyak. Teşekkür ederim. Shukran. Thank you. What?
Thank you very much, Professor Masao Furusho and also Dr. Trikapitana. Hopefully, the good relation and collaboration between Kobe University and ITS will increase and improving the research towards better technology and innovation in the future. Ladies and gentlemen, our next agenda is photo session. So make sure that your webcam is on. And I would like to ask to all the participants to gather into their laptop because our next agenda is photo session. Well, yeah, since the agenda is online, our photo session is also online. But I hope our spirit still remain high. Okay. 1, 2, 3. MASTIC 20 and 20, Maritime Safety International Conference 20 and 20, responding to future's technological challenge and opportunities in maritime towards safety, operation at sea, and environmental protection. Thank you very much. And our next agenda is we will hear our keynote speaker. And this part will be led by our Pledo keynote speaker, Dr. Trikapitana, as a moderator. Dr. Trikapitana, he has served as the Dean of the Faculty of Marine Technology since 2019. He has earned Doctor of Engineering from Kobe University in Japan. He graduated from Marine Engineering ITS Surabaya and completed his master degree in World Maritime University, Sweden. His areas of research interests are IES research, marine safety, and future and change in international legislation. And also, we would like to welcome with an honor, Dr. Trikapitana as a moderator. Time is yours.
Okay. Thank you very much for opportunity to the master ceremony. Please allow me to introduce myself. So my name is Rika Pitana from the Faculty of Marine Technology and Marine Engineering departments, and now there is in charge as a dean of Faculty of Marine Technology. So for the keynote session, we have three keynote speakers. So we started from the farthest one, Professor Dr. Serdar Kum. Then Professor Dr. Serdar Kum is, I would like to read the curriculum vitae of Professor Dr. Serdar Kum, then followed by Professor Dr. Adi Maimun. Then the last one will be delivered by Professor Dr. Ketut Buddha Artana. And I believe those are very prominent professors. So Professor Dr. Sidarkum, he has served as the vice rector in ITU North Cyprus since 2015. And he received his associate professor degree twice. The first one in 2012 in the field of management and strategy, and the second one in 2017 in the marine and ship engineering. And he has earned PhD degree in maritime science and technology from Kobe University in Japan, 2008, and previously also my neighbor college in Kobe University. Our room is very near actually. Then he also graduated from the Tech Department of ITU Maritime Faculty and completed his master degree in Maritime Transportation Engineering. He also holds ship master license. His area of research interest are human element, mental workload, risk analysis method, and risk assessment in maritime safety and security management system and maritime simulator. And his recent interest is in human resource management and organizational behavior in the field of strategic management in maritime. So, because time is very limited, so we can start the keynote speakers. So, Professor Dr. Serdar Kum, time is yours.
Thank you very much, Chidika Sensei. First of all, thank you very much for everyone, and I'm very happy to be with you. Could you help me? Can I share my screen or my presentation?
Yes, sure. Yes, sure, Professor.
I think now everyone can see my screen. Today, I'm very honored to be with you for the existing or current research from the Turkey. And I want to give the brief information about that. Turkey coastlines, as you know, Turkey three sides of has got the coastline, and we have 25 AIS base stations since 2007. It means that we can observe and record the IS tracking. Later, Turkey will vary projects about this IS based on our IS. So we have got now 4 regional VTS stations. It means that 7 VTS center. Now 6 of them is activated. So it means that the government of maritime administration has got very huge data on IS to follow, to track the ships, or to get the dynamic or static information from the ships. So the researchers has got the very big potential to obtain, getting from this data for their research activities. As now, for example, we have got the two, as you know, two straits, important straits for Turkey. The first one is Istanbul Strait, and the second one is Çanakkale or Dardanelles Strait, as you know. Now there is a big construction for the first time for the Çanakkale Strait for the bridge. For example, they have to decide the food of the bridge and how they will decide what is the effect of the maritime traffic. All these research activities getting from the basic data of the marine traffic by using the IS. So there is a many research, but today I want to share one of our projects. I am the minor of this project as far Eurostar projects. At the beginning, we have the four company, but later we became the academicians became the consultants. This is the Eurostar product. Name is Intelligent Telematic and Safety Solution for Sea Vessels. The partners, there's a three partners: Danelec Electronics, Vessel Performance, and I'm money from Turkey. And I am the consultant, and two of my colleagues, Dr. Yıldıray Ertaş and Dr. Yunus Emre Şenol, is the consultant. And the algorithm of these projects is the produced by the Dr. Emre for his PhD study. The main objective of this project is to develop a dynamic navigation risk assessment tool. As you know, the transportation is mainly by the sea. So, according to EMSA reports, there is a very huge numbers of accidents and incidents, and 50% of them is collision, grounding, and contact, according to this report. Of course, as you know, the main factor for this is the human factor. So, for preventing of these collisions, electronic equipment, navigation technology has become very widespread for that. So we have the modern navigation equipment also. So we have the real-time data for following the navigation status. According to that, we think that if possible, we can produce a anti-collision or anti-grounding systems for helping the navigators, captain, and the others. The studies in the literature are usually deals with the pre-reliability or simulator output. So lack of the proactive decision support for preventing collision and grounding, we start this project. How we will, what is our objective? Mainly we have the two input data. The first is the IS, the second is the ACTIS data. And we will use this data to create a real-time navigation risk analysis algorithm. And we will compute based on the multi-point ship form. And we will combine to integrate navigation equipment and run onboard a real ships. Then utilize it for performing an objective officer's evaluation process. Now we already finished, but the based on the pandemic, we just finished the prototype. We cannot come the forward section of performing the navigation officer's evaluation. The proposed model is capable of working on board in real time, and it will use IS data for traffic information. It uses ENC, electronic navigation charts, for land and shallows data. We will perceive all shallows as multi-point clusters, for the increase the reliability, perceives all ships as multi-point cluster with real dimensions, employs artificial intelligence we will use. How we will get data obtaining? There is a 4-module we propose. The first module is IS data obtaining. The second is chart module, electronic navigation chart. Third is the algorithm for the computation module. The fourth is visualization for showing and demonstrating of the risk for the collision and grounding. As I mentioned, the required data gets from the ACTIS and IS. How we will get IS data? We will use the voice data recorder by the we will use the connector with the as you know NMEA connector for the data exchange protocol. Let me to talk about the IS data obtaining module. You know the requirements of IS. That's why I don't want to bore all participants. Almost all ships, you know, there is 2 types, Class A and Class B. Our models can receive all the data for the international and national voice. The system is the interface with the GPS, ACTIS, and ARPA and gyro for the required dynamic data. Do you know the IS provides the 4 types of data: static informations, dynamic information. I will not get the deep because I think all the participants are familiar with these issues. And voice-related information data, and finally, safety-related messages. So, how we will get the IS data obtaining model? You know, data from this is the flow chart of the IS obtaining model. Data obtaining in NMA format, and we have to make the IS decoding and IS parsing. When we make the IS parsing, we can classify or separate the data. Then we will identify the message and eliminating which data we will use. We will use for the A class and B class. There is a heading, course overground, and speed overground, for example. Then this is the remarkable output for the IS data, and this is the demonstration for that. This is the base of the IS data obtaining model. For the ENC model, this is the flow chart of that. As you know, we have the very big data for the S57 standards. So, which data we will use for that? Surrounding depths and points and the others will be defined according to that. Then there's a two parts of the chart model. One is the descriptive attributes and the other is the geographical attributes. We will use these informations to extracting the objective for the grounding risk, and all this information will be storage a chart container for final illustration. This is the base of the coastlines information ships, and for the final risk showing, we have to storage in the chart container. Then computation model. In the computation model, we will use the fuzzy interface. We use some experts to that, but mainly the flow charts will showing you. I can summarize that. we didn't take only one point or only one domain area. In the literature, you know, there's many studies about that. We use the ship's dimensions, and also we use all the points as a computing or calculating the risk from the collision or grounding for the reference points. And we makes the very short interval with the 10 minutes, 10 meters. Of course, it can be increased, but the computer or the calculations or simulations cannot test or cannot make a in a dynamic situation. For the dynamic case, it is very we can hand for the 10 meters intervals. For the visualization mode, all perceived and calculated data are sent and converted to visual part. We use the, as I said, the standard chart module S57. We use the multi-point ship source and dimensions and risk outputs. For the interpolation phase, it's the same. Let me show. This is the flow chart of that. We have the we have the some overlays. It can be separated or it can be make a or layer overlay. So in the visualization mode, we will use the for the final case. We can see the actual electronic navigation charts and routes and ships proceeding for the final visualization. This is the just a screenshot for the visualization model. And as I said, this is a tool, as a dynamic tool. Of course, this is just screen. Dynamically, according to on-ship position from the geometrically and for the grounding and also for the collision risk for the other ships targets. This is the showing the percentage of collision and grounding. This is the risk degree. I will talk about the later, but we have defined the three list level according to fuzzy. Low risk as a green, and medium risk yellow, and high risk by showing by red color. Fuzzy interface system, as you know, fuzzy logic was first introduced by the Lotizade in 1965, and it can be changed for the from perception of human. That's why we use the experts for the input of the fuzzy interference system. I don't want to go to deep detail with the explain of this system, fuzzy interference, but the most important thing, fuzzy interference system deals with the converting reasoning process of human thinking way by using if-then rules. The most important part for our model, we use very huge if-then rules models. A typical fuzzy interface system structure has got the fuzzification knowledge, rule-based interface, and decodification models. This is showing that how this mechanism is working. There's a crisp value. As I said at the beginning, the perception of human can change. So we have to fuzzification of these crisp values and defuzzification of. For that, we use the Mandani, a fuzzy interference system was proposed as the first attempt and control a steam engine and boiler combination by a set of linguistic control rules obtained from experienced human operators. In the fuzzification model, for example, we talk about the fast, and according to that, the result of fuzzification will be like that. When we input the linguistic terms, we set the rule-based model, if-then rules. For example, the speed is slow and range is far. If like that, the risk will be slow. According this rule-based, for the collision, there is we produced with the experts 20,916 combination. But later we, because very huge, that we categorize and shortest, finally we get at the 126 rules for our algorithm. Similar case with the grounding, the combination, total combination was 486. Then finally we obtained 96 rules. All the showing that, for example, this is the first part for the if-then rules. If the speed is fast, then and range is close, the risk will be high. This is the consequence. And how we will demonstrate this risk? After that, we will focus this part. Then we only focusing on this area. For the defasification of this area, simply and basically, I can say that when we focus this area, the output is the risk will be indicated as a like that.
Professor Serdar, 2 minutes remaining. Oh, it's the conclusion.
Yeah, now I'm coming to that then. Thank you very much for reminding. What is our strengths for that? We include all possible factors that affect just only for the collision and grounding. Ships are not considering only a single point. We use it for multiple points. And set of multiple point consists of the distance is the remarkable distance with the 10. And although already we run this model with a real type ships with the RoRo ships. And it is a support the decision making for the increasing of situation awareness of the watch keeping officers. And this model is also able to support the VTS operator by tracking the ships or by following the ships if they are going to dangerous situation for collision or grounding. And the model will constitute a starting point for autonomous ship technology on navigational safety. Thank you very much for listening to me.
Okay, thank you very much, Professor Serdar. It's quite very interesting. So your research relating to the dynamic risk assessment by utilizing AIS data. So giving applause to Professor Serdar. So we will finish all the presentation. Then later on we have the Q&A. So the second presenter is Professor Dr. Adi Maimun, Professor of Naval Architecture at Department of Aeronautics, Automotive and Ocean Engineering, Faculty of Mechanical Engineering, BSc in Naval Architecture from University of Strathclyde, Glasgow in 1983, Master and PhD in Marine Technology, and obtained his degrees from the University of Strathclyde in 1985 and 1993 respectively. Research area in marine vehicles or structure dynamic using CFD, AIS, time domain simulation, and experimental works. Currently a fellow member of the Royal Institution of Naval Architects, UK, and a chartered engineer, head of Marine Hydrodynamic Research Group, UTM, 2010 until present. So, time is yours, Professor. Prof. Adi probably is mute. Could you please unmute? Oke, sudah. Oh, hilang. Oh, probably is there is some technical problem from Dr. Adi because it's not not appears. Oh, so it's just coming again.
Hello.
Okay, Prof. Adi, please.
Yes, I'm back now.
Okay.
Yes. I think you just lost the connection just a while. I would like now to yes, I want to share my screen now. I hope this one works. Okay. Can you see my screen now? Hello? Can you see my screen now?
Not yet, Professor. Just is coming. Will be coming. Yeah, yeah, it's not it's clear. So it's okay. No.
Okay. It takes time maybe. Okay, now okay, is it? Can you see my screen now? Hello?
Yes, yes. It's very clear, Prof.
Hello?
Yes.
Dr. Trika? Yes, yes. The problem is when I try to share my screen, okay, I'll try it again, see whether it works or not.
It's coming, Prof.
Yeah, okay?
Yeah, okay.
Okay, now, thank you. Okay, can you hear my voice now? Okay?
Yes, it's very clear.
Okay. So, Assalamualaikum warahmatullahi selamat sore and good morning. So this is the title of my presentation. I hope everything, I'm not too sure whether this works well or not. Okay. Okay, the title is on the utilization of AI data. Basically, it's our R&D work in UTM for the period of the collaboration with Kobe University, ITS, and Istanbul Technical University. So my presentation outline, I start with a small introduction. Marine traffic straits of Malacca, our AI facility at UTM. Firstly, I start with the work on collision avoidance and followed by marine pollution, dredging import research. Okay. So my introduction is first visit by Professor Ishida in 2008, followed by Professor Kobayashi in 2009. Then after some discussion, we agreed to install the AIS facility at UTM. And after that, we signed an MOA with Kobe University in 2010. This is the Straits of Malacca, where we are doing basically our research, especially just connection between the Straits of Malacca and Straits of Singapore. So this is one of the busiest strait in the world. And also there is a traffic separation scheme because of this congested area. As explained just now by Professor said, AIS is mandatory to be carried out by all vessels of merchant vessel 3,000 gross ton and above, and also cargo ship of 500 gross ton upwards. Okay. So this is a brief description of the AIS. Basically, with AIS, we have this data of position, speed, and cost of the vessel that has installed the AIS transponder. Okay, and now basically the collaboration of the UTM with Kobe University, ITS, and Istanbul Technical University is basically to see how we can utilize the AIS data that we received. This is the AIS facility. Basically, is quite common. So we installed the antenna at our our highest point is the observatory station, and then we use microwave to transfer it to the marine lab at lower height. So this is our possible area, about 50 kilometers, for us to track the vessels. So this is basically our system, receiver, and then we transmit to the laboratory, and we also develop some web page for us to access the data through internet. So we have a web page. We use the PHP language system, AIS data stored, and use the SQL database software to store the data. And from there, we got a lot of data for the vessel flying near the Straits of Malacca and Strait of Singapore. So this is just a overview of the web page we have at UTM, which is the AIS Management Analysis and Visual Console. This is showing the area that we can select to study the vessel movement. Say in this rectangular area is where the vessel of interest, and the straight line is you can consider as our observe or subject vessel, to see the interaction between the other vessel in terms of crossing, heading, or overtaking. So from here we can see track the vessel. So we have the name, ship type, dimension, and also the tracking of the vessel in the AIS data. So this is our first task that we did with the AIS. So we have the risk assessment to identify the hazard, estimate probability of frequency of accident, consequence of hazard, some qualitative assessment of the risk, and identify measures to be taken to reduce the risk. So this is our target in using the AIS data. So firstly, what we do, we collect the data and we see how many vessels that we can track. So we divide it into head-on, overtaking, and crossing, relative to our subject vessel in the straits. And our approach first is to use the probability of collision. That is using a probabilistic approach. This is the traffic density. And also we use the collision situation, head-on or crossing or following. This is probability of head-on overtaking and crossing collision. So this is the probability of collision for the whole situation, and we can even refer to the collision for in a per year basis. And we have, in the end, we come up with some probability of collision for the situation that we had considered, head-on, overtaking or crossing. And we can total up this probability for 1 year. Okay, so and then we compare with the standard of probability. So this is one example that, so we may have, say, from based on our study, we can judge the how frequent the collision is, and from there we can estimate the risk. Because there is one method that we can do. So we also use, I think all now almost quite common now to use fuzzy logic, as I mentioned by Professor Serda. Basically what it does is try to evaluate the risk by incorporating some human judgment, you see. So if you have some distance and speed, we can combine these two input and then use human judgment to come up with the risk. So that means higher speed, short distance will just create more risk. So this is the fuzzy logic rule. So this is where you use your human judgment from the distance or speed, and you can grade it at the low risk or high risk situation. So we using the fuzzy logic and probabilistic, we compare these two methods. Of course, the values are not the same, but it does give an indication where the higher risks are. In this case, of course, ship crossing becomes an indication that it is of higher risk in the Straits of Malacca. After you identify the risk, the next thing is, can you use it for collision avoidance exercise? I mean here, because we don't go for real time, because we found that the data that we got is not really real time. Is some delay. So I thought this data may be useful in creating some exercise for navigators to avoid collision in the Straits of Malacca. So basically what you use is just DCPA and TCPA, closest point of approach, and time, and also distance. From there we can judge how the risks are. So the closer the shorter the DCPA and the shorter the time, TCPA will have a higher risk. So these are the data we got from the ICE, and you can process some data as well, the DCPA and TCPA, and also relative distance from the AI's data. So again, we use the fuzzy logic again. So this we use it two levels: identify the risk, and also use fuzzy logic to do some mitigation for the risk. So by using DCPA and TCPA, we first identify the risk collision, and then we can use it to decide whether you want to do reduce speed or change course to reduce the risk of collision. Okay, so this is the fuzzy logic for collision avoidance. So you are using the collision of risk and collision situation, combine them together to decide whether we have to change our speed or change the course, or both. So this is one situation of overtaking situation where, based on the risk that evaluate, using fuzzy logic, the vessel or the navigator decide to increase speed and change heading to port to avoid the collision. So this is what we can conclude at that time, so that we can use the AIS data for probabilistic and also fuzzy logic method to identify the risk. And when you compare the fuzzy logic and the probabilistic method, we think the fuzzy logic method gives a more realistic assessment compared to the probabilistic method. And fuzzy logic approach can also be used for assessing the risk as well as avoiding action to reduce the risk. So that's one of our area. The next area is we can also use the AI data for looking into emission of ship exhaust in the Strait of Malacca, because a lot of ships in the Strait of Malacca, so there will be we expect to have a lot of this pollution as well coming up from the ship exhaust, emission of SO2 and so on. So the objective, that's the objective of the vessel, basically to estimate the emission and also to estimate the distribution of the emission in the Strait of Malacca. And I think Dr. Trika would remember that when we did some communication with Dr. Trika as well to use the MIT methodology, as I show here now. So the way we calculate information, we use the MIT methodology, and also determine the distribution of the dispersion using the Gaussian path model. So this is what AIS can do, can get data for the vessel. So this is type of vessel and number of ships in the area. This even we can get the number of vessel based on the country flag. This is, again, I mentioned MIT methodology in calculating the emission and energy consumption. So here you can check the fuel consumption, and also what's important here is the total emission can also be estimated from the different class of vessel. So this is the MIT methodology, okay, for fuel loading based on either it's cruising, hoteling, or maneuvering. So this is the area we can consider for the emission, cruising, maneuvering, and hoteling. They're all of them give different emission. So this is the phases of cruising, maneuvering, and hoteling, and this is the emission that can possibly be emitted. NOx, CO2, CO2, this VOC, and SOx. Okay, so these are the data that we can obtain from the estimation. And we can also check, yes, the CO2 and so on. So I'll be quick here. So these are all data. So here you can check how the emission being dispersed by the wind based on the wind speed and also the direction of the wind. So these are the dotted points here are the receptors. So in the end, we can conclude where are the emission is maximum, where we found that the most will be in Sentosa Island in Singapore. Okay, so that is the second approach, or the second R&D we can do for estimating emission, starting with the risk. So we also tried using the A data for port dredging planning, because once you do dredging, the port will not be working at the maximum. So some of the vessel have to the servicing of the vessel will be reduced. So this is data on Straits of Malacca, and particularly we are looking at the Port Tanjung Pelepas, a big container port at the southern tip of Malaysia. So this is the research methodology where we collect the data and do some modeling and develop some simulation program. And we have some scenarios and condition of blocking berth, priority for the vessel navigation in the channel, increasing the period of time for dredging process. And then we can conclude the effects, how the effects of dredging operation on port capacity and some recommendation for the port. So this is the port that we're talking about, Port Tanjung Pelepas. So this is the channel to the port. So this is local location, as I mentioned, this is PTP here, around here. So we have a lot of data being collected around this area. So these are the specification of PTP, got 14 berths, sheltered, about 15 to 19 meters, 12.6 kilometer length of harbor, also a turning basin. So these are AI's data collected. There are the number of ships. Okay, so days per month, hours per month, and number of ships in different months. So from there we can calculate the ship arrival rate, the ship per hour for different months. And then this is the workflow of the research study. So first we collect data from the port as well, AI data, dredging data. And the next step is to do a vessel traffic queuing. Plus also here we use a discrete event simulation with a queuing theory. From there we can come up with the effects and recommendation for the port. So this is the queuing simulation. Queuing simulation is basically based on statistics that they collect in the port. And from there, we can estimate the number of ships to be produced. But this only usually give in terms of number, but doesn't show the visually how the vessels, the port are affected by the dredging. So we use here the discrete event simulation. Basically, it's just to make the event discrete into anchorage, channel, going into the channel, berth, turning basin, and channel outbound and departure of the vessel. So this is basically the simulation program where there is a sort of queuing, and then once the vessel is okay to go inside the channel, then it start. Then after that, it goes through the berth, turning basin, and outbound.
Professor, 2 minutes remaining.
Okay, thank you. I'm just about to finish to conclude. So here we can, based on the simulation, we can compare the number of ship service in the port, normal condition without dredging, and bottom one is with the dredging, and we can see the difference with and without dredging. And here also we can show the difference, and also we consider the container vessel and non-container vessel as well, because the port also have utilized the same channel for non-container vessel. So here we can conclude that AI's data can also be used for evaluation of port capacity by using discrete event simulation, and also with the queuing theory. And data obtained from the vessel traffic simulation is able to be applied for forecasting impact of dredging on the port capacity, because the port really have to continuously dredge the port so that the large vessel can enter the port. So the simulation can be upgraded in future for, also we can include combined with the navigational risk with dredging operation in future. So we can actually use a lot of this IAS data to assess not only the navigational risk, but also how the port is being affected when there is some kind of dredging or other activity that can reduce the frequency of the vessel using the port or entering the channel within the port area. So with that, thank you very much for your attention. Hopefully you can hear me well. I'm not too sure Okay, Dr. Trika, I'm finished now, and thank you
Okay,
for
thank
the
you,
audience.
Professor.
Thank you. Okay.
Yeah, yeah. Thank you, Professor. It's very interesting presentation. So we come up with the last presenter and the last keynote speaker, Professor Dr. Ketut Buddha Artana. He is a professor in marine engineering, Faculty of Marine Technology at Institute Teknologi 10 November, Indonesia. He currently serves as a head of a safety laboratory, and he won Academic Leader 2019 in field of maritime science. Previously, he has served as the Vice Rector for Research Innovation Cooperation and Alumni, ITS, from 2014 until 2019. He has earned PhD degree in Marine Technology, Kobe University. He graduated from Marine Engineering ITS Surabaya and completed his master degree in Marine Engineering University of Newcastle, United Kingdom. His areas of research interest are system reliability, static engineering, marine safety, risk assessment, and LNG technology. This is another prominent professor. So, Professor Ketut Buddha Artana, time is yours, please.
Thank you very much, Dr. Trika. Can you hear my voice?
Yes, it's very clear, Prof.
Okay. Good morning, everybody. I'm very happy to be able to be with you all, especially our colleague, my senior Professor Adi Maimun of University Teknologi Malaysia, and then my dear friends, my colleague, Professor Serdar Kum from Istanbul Technical University. And for sure, I'm very happy to meet all the participants of MASTIC 2020. My name is Ketut Buddha Artana. I'm from the Center of Excellence Maritime Safety and Marine Installation of ITS, and I belong to the Department of Marine Engineering of ITS. Today, I'm going to present my rather a different approach to what been presented by previous speakers. Try to explain about the automatic identification system in terms of the implementation for improving maritime safety in Indonesia through the development of automatic identification system of ITS. Has been also mentioned by the previous speakers that the utilization of automatic identification system been enacted by the International Maritime Organization in 1998 and then come into force in 2004, if I'm not mistaken. And this regulation requires the ship to install AIS for all vessels of more than 300 GT. As we can see from this figure, at the upper figure, you can see the typical appearance of AIS class A and then AIS class B. And then we have also a picture of the AIS receiver and then the antenna. Actually, as we can see from the figure, AIS is quite simple equipment devices that, but behind that, the AIS very much functional in order to improve the safety navigation of ships. And it's also been mentioned that there are two types of data we can obtain from the AIS. The first one is the static data. Basically, it is the identity of the vessels, and the second one is the dynamic data, which is the data belong to the vessels that change every time, like position of the vessel, speed, course overground, and so on. So based on this feature, I think we still consider that AIS is a simple device. But today, I would like to share with you the power of AIS when we combine the AIS data with others data. The government of Indonesia is rather late in responding to the regulations. And finally, in 2019, the Ministry of Transportation of Indonesia been issuing Ministry Decree number 7, the year of 2019, and then renewed by the Ministry Decree of number 58 of the year of 2019. This regulation requires AIS Class A or Class A AIS to be installed and utilized for all vessels, Indonesian flag that fulfill the SOLAS Convention. And then B Class AIS to be installed and used by all passenger ships and non-conventional cargo ships with a capacity of more than 35 gross tonnage. And also at the same time, B Class AIS to be installed on fishing vessel of more than 60 gross ton. This is a very new breakthrough from the Indonesian government just to ensure that the safety operation of ships is achieved in Indonesia. But to my understanding, there are 6 challenges that we need to consider in the near future on the implementation of AIS in Indonesia. We call it 6C. The first C is the coverage. As we know and understand that the coverage area of AIS station in Indonesia is still quite limited. This is because the less infrastructure we have in Indonesia. The second challenge is the compliance, or in this case is how we could enforce the law so to maximize that the ship install and operate the AIS, just to make sure that all vessels can be monitored by the regulating body, and then the safety operation of ships can be increased. The third challenge is the capacity of human resources, including research and development. As we understood that not many people doing research on AIS. As far as I know, I think the member of consortium of AIS with the leader of Kobe University are working very actively in doing research on AIS. So in this case, institutions have a very important roles in, delivering the idea, the research and development that they perform in each university with the focus of the AIS. The fourth challenge is the consolidation of data. For example, in Indonesia, we have quite many AIS stations, but the problem is how we can coordinate, we can integrate the data taken from one station to other station. So this is a very much important challenge that we need to solve. The fifth challenge is the cost. By the implementation of Ministry Decree number 58, the year of 2019, then we need to make sure that the AIS hardware need to be provided in a cheaper manner, because just to make sure that all vessels, especially the fishing vessels, can have the equipment and then can be used to monitor their activities. And final, the 6C is the combination with other data. Our center in ITS tried to focus on the last C, which is we try our best to combine the AIS data and with other data, and we developed several applications to be used by quite many users. I will explain the detail in the next slide. So with that situation, I think we believe that AIS is very much capable of providing us with quite many services, not only for vessel identification, but in our center, we try to develop application to utilize AIS data with the combination with other data to develop real-time monitoring vessels. And then to have early warning system for vessel, early warning system for marine installation, and then also for fuel consumption monitoring system, emission monitoring system, and then risk assessment for vessel, the things that also been presented by Professor Adi and Professor Serdarkum. And then there is a possibility of combining AIS data with other data to monitor the cargo itself, and then in order to support the logistic. I think those application has been intensively performed here in our center. Next, I would like to introduce to you some recent development of AIS ITS. This is the trademark of our application, automatic identification system produced by ITS. And before I explain about AIS ITS, I would like to share you one video showing the launching ceremony of this application. This official launch of AIS attended by Ministry of Transportation and Ministry of Research, Education, and Research, Technology, and Higher Education was held in Jakarta in 2009. Okay, can you still hear my voice?
Yeah, it's very clear, Prof.
Okay then. We developed AIS ITS in two forms. The first one is web application, and the second one is mobile applications. And currently, it's been utilized by one oil and gas company located in Balikpapan to monitor the safety of subsea pipeline, subsea cable, and their offshore platform. So this early warning system has been come into market. And then at the same time, also developed the application of AIS for ship management and then for ship safety monitoring and monitoring potential of ship exhaust emission has been also clearly discussed by Professor Adi management. The development of this application again started with the generosity of Kobe University through Professor Kenji Ishida, Professor Masao Furuso, Professor Eiichi Kobayashi, alongside with Tokyo University, Osaka University, University Technology Malaysia, National Maritime Research Institute, Ulusal University, and Istanbul Technical University. And then after the joint research, we been supported by Ministry of Research, Technology, and Higher Education with some research grant. And then finally in 2018, if I'm not mistaken, we had soft launching of AIS ITS in Surabaya. And then finally in 2019, we come into commercialization with the cooperation with PT ITS Technoscience and PT Bali Towerindo Sentra. So for that, I will like to sincerely thanks three professors, especially Professor Kenji Shida, who passed away several years ago, and then Professor Masao Furuso, as well as Professor Eiji Kobayashi, who just also retired from Kobe University, because of their generosity, their effort, and their support that I think quite many universities, especially in Southeast Asia, can now feel the challenge of doing research by means of automatic identification system. This figure shows the research board of AIS-ITS in Surabaya. As you can see that the research member not only come from one department, but from many departments and many universities. Some from Polytechnic, some from Universitas Negeri Islam Surabaya, some from Universitas Muhammadiyah Surabaya, and many other institutions. The AIS-ITS platform is shown in this picture. So basically, we receive data from the AIS base station installed in many places. Through AIS receiver, we could receive quite many AIS data. And then all of those data will be stored in our scientific solver, in the server. And we combine those data with quite many other data, SIP database, and then platform coordinates, pipeline coordinates, subsea cable coordinates. And then by means of algorithm we develop in our center, then we use those data in several applications. One of the application is the early warning system for marine installation. So by using this system, then we can monitor the safety of our facility through a big screen. Or you may check the safety of your facility through email or through mobile phone. Basically, the AIS-ITS platform is composed by means of this concept. The first one, as we can see here, we use static and dynamic data we obtain from AIS. And then we combine with the shipping database, and then we combine with environment database, the pipe, cable, platform database, and other data. And then we combine those data and we implement several algorithms we developed in our center to be implemented to monitor ship position, to track the vessels, to monitor the consumption of fuel, to monitor the emission, the collision avoidance, oil spill monitorings, and these three has been, as I mentioned before, has been commercialized. Early warning system for subsea cable, early warning system for subsea pipeline, and offshore platform. So by means of this application, I think quite many issues that have been faced by Indonesian government can be solved. The issue on dwelling time, environmental protection, port security traffic, and then, port security, traffic separation scheme, and many others, including the energy monitoring. One of the applications that we are now intensively perform in our center is how we could utilize the AIS data in the combination with the cargo data to monitor the movement of the cargo from the origin to the destination. We call it as the AIS-ITS log, because this will support the logistic management of a ship. And then we also develop AIS-ITS for vessel management in port. So the concept is we combining the AIS data with several devices, has been also mentioned by Professor Sadarko, combination of AIS with the CCTV, electronic chart, radar, and so on. So this will be able to support the port, manage the vessel when the vessel comes to the port. And then fuel oil monitoring is other issue, very, very important issue, with the effort of many shipping companies to reduce the fuel consumption cost. So by monitoring, by using AIS and using one channel of the AIS data, then we could send all information about the fuel consumption to the headquarters. So using this one, then the utilization of vessels, utilization of fuel oil of the vessels can be monitored in real time, and other mitigation can be done through this application. And then we also developed the monitoring system, emission monitoring system, by using AIS data. As we can see here, there are two figures. This figure shows the distribution and concentration of NOx in the Madura Strait. By using this figure, we could collect the data, the potential of emission in a certain area in which the vessel is operated. This issue will be very much important when we consider the implementation of carbon trade. Then the government could decide it with company to be provided with incentive, for example, in tax, by operating clean vessels. And then this is the things that also the same performed by Professor Adi Maimun. We utilize AIS to measure the risk based on several variables. From the AIS and the shipping database, then we could find the type of the vessel, the flag, the classification society, and the age of the vessels and other variables. By utilizing these variables and implementing certain algorithm, then we could calculate the inspection score. As you can see here, different vessels have different colors. It means have different, different inspection score. This will support the port authority to make sure that inspection for the vessel can be performed effectively. So inspection can be implemented for only vessels having the highest inspection score. And currently we focus on the development, the research on the antenna, because this is very important issues. As by default, the capacity of AIS antenna data, the coverage is 70 kilometers. But with our research, now we can cover until 150 kilometers. And sometimes we can cover until 300 kilometers. And the target of our research and development, whenever possible, we would like to, our system can monitor 100 kilometers. As you can see here, this is the installation of the antenna in ITS, the Yagi antenna. We combine the antenna, the Yagi antenna with Omni antenna, so we can have a further coverage area. This is the coverage area we currently obtain through our infrastructure. So basically, we now cover all of the Java Sea.
2 minutes remaining, Prof.
Okay, I will make it fast.
I'm sorry, 2 minutes remaining.
This is also coverage in Balikpapan. This is the facilities we have with the cooperation with PT Bali Tower. And then this picture shows the some activities of our graduate who install and implement application in one oil and gas company in Kalimantan. But before stopping my presentation, I would like to show you some. Wait a minute. So as you can see here, this is the our application AIS. We can monitor all vessels in the state, and if we click one vessel, then all information about the vessel can be obtained, including the score. And this right menu can show you how many vessels potentially affect vessel, whether as you can see here, this pipeline located in the Madura State. One vessel entering this restricted area, and as you hear, some then that indicate that one vessel entering the restricted can put the risk to the pipeline. I think that's in my presentation. Thank you very much for your question.
Okay, thank you, Prof. Ketut Gartana, for your very interesting presentation. Yeah, sorry. So before we started with the question and answer, we still have 20 minutes. So giving applause for three presenter, for three keynote speaker, because it's for the very excellent presentation. So there are already some questions arise in the on the chat Q&A box. So the first question is from Dr. Lahar Baliwangi. I suppose that Dr. Serdar know very well Dr. Lahar in Dom UAE right now. Question to Prof. Serdar: how far we can reduce marine accident when AIS-based ship collision and grounding avoidance system is implemented in Turkey? This is the first question to Professor Serdar. Then the second question is from Yedit Polytechnic Negeri Banyuwangi. Supposed to be to three presenter, three keynote speaker. Can I apply AIS technology to the fishermanship and connect to cell phone, because our fisherman problem is cannot call a help if there is something happen to them on the sea. So it's supposed to be for the second question is for three keynote speaker. And there is another, the last question from the first session, because we are very limited time, from Yoga, PHE WMO, PHE WMO. Question to Prof. Serdar. I suppose that Prof. Serdar has there are so many questions to Prof. Serdar. In real case, it is difficult to differentiate whether the ship is still moving in the every slow speed or it is already stopped and did the uncorrect job. So in my limited knowledge, after watching your presentation, is there any reason that explains the range of ship speed, especially low speed, which can still cause collision between ship or in the medium risk category based on your presentation? I suppose Professor Serdar can answer first from the Dr. Lahar, how far we can reduce marine accident when AIS-based ship collision and grounding avoidance system is implemented in Turkey. Dr. Serdar, please.
Thank you very much. This is a very hard question for me, but honestly, you know, the European country and European projects try to reduce the human error, and that's why they are focused and very huge research budgets for the autonomous ships, unmanned ships. So, and also I believe that it is not possible in near future, but we are trying to make the unmanned because we reduce the human factor. So what I want to say that, yes, it can reduce marine accidents, but not, we can say minimize, but it doesn't mean completely will reduce, because, you know, there is a, this is just a decision support system, collision or grounding cases. Normally, it gives we can make the combination with the electrics. So we can understand which ships is more by using the CPA and TCPA, or we using the depth counter. We are going to shallow water. Just giving the attention to the watchkeeping officer. And also we are thinking maybe we can connect with the bridge Biennially, bridge navigation watching as alert system. So it gives the time for prevent the collision, to increase the time to understand the situation, for example, there is a TCPA limit, but officer cannot decide is it risky or not. So this system can just give the advice. It will minimize, but not completely reduced. Thank you very much for this question.
Thank you for your explanation. So basically, the question is how far is mean that probably it's very deep. How far mean is more in how many percentage probably it can reduce the marine accident, in your opinion, Professor?
Just I can guess, but there is no any experimental study on simulator or real case. According to me, it can reduce not 50%, but maybe maximum 20%. This is my idea because human-based center.
Okay. Thank you, Professor Seder, for your answer, because there is no any data how many percentage basically, but it's possible to reduce. And for the second question, for all the presenter from Yedit Polytechnic Negeri Banyuwangi, can I apply AIS technology to the fisherman ship and connect to the cell phone? Because our fisherman problem is they cannot call a help if there is something happen to them on the sea. Okay, probably from Prof. Saidar first to answer number 2. Can you get my questions? Can I apply AIS technology to the fisherman ship, fishing ship? I suppose that the name is a fishing ship, and connect to the cell phone, because our fisherman problem is cannot call a help. So is it possible or not?
I can give my opinion and my experience that, if possible. Briefly saying that in Turkey, the first class B is start for the fishing ships, and they make a system buggies in Turkish, following and tracking the fisheries, such kind of thing. So they use the class B IS, and they used another very small charts display for understanding their situation. And also for the mobile phone, they make a system for in an emergency, like a ship security alert system, just like a button for the alert case. It can be applied. Thank you very much.
I see. So thank you, Professor. So this means that it's possible to connect with cell phone, right? Another ideas, because I mean that there is some possibility that we can utilize in the fishing vessels. So is there any opinion from Prof. Adi or Prof. Ketut? Prof. Adi, probably do you have any opinion regarding the questions?
Okay. Yes, we had last time considered this for the fishermen. Basically, just tracking the fishing boat using the AIS. I think the main problem with the fishermen is the cost. So it's a fisherman doesn't have much money. So even the class B, also they're worried that they may not be able to afford it. I think one way we considered last time was to have build our own AIS in the country, right? Because the problem with the AIS, you must be able to transfer the data. You cannot use the satellite; it's too expensive.
Yes.
So what we can do, we put some receivers on the buoys, you see, so that when the fishermen send their signal or the position, the boys can pick up the signal and then transfer it to various buoys until they reach the land, where people can monitor their position. Also, Professor said, I agree with him that we can use some kind of special button that the fishermen can transmit if they are in trouble. So I think it's possible using the smartphone. Now if you can communicate now, you can via the internet, and you have some station like the same with the smartphone, right? You need this land-based station. So at sea, what you do is just put some buoys with some antenna, to receive the signal and also to transfer the signal until it reach land. So I think there's no problem. It can still be used, but still this system must be developed. If you want to reduce cost, then every country should have their own system. AIS is not it's not a high tech. It's not high technology. I think we can develop it ourselves. Okay, that's my opinion.
Okay, thank you, Professor Adi. Is there any additional information from Prof. Ketut? Prof. Ketut, please. Do you have any additional information?
Thank you, Pak Trika. Pak Jedid, our colleague from Polytechnic Banyuwangi, it is very feasible to monitor fishing vessel by using B-class AIS because it's come into regulation in Indonesia. And for your information, we are very proud that one polytechnic in which we work with, Polytechnic Madura, been developing B-class, very cheap B-class AIS. And by the end of this month, we are going to grant AIS to your university, to Polytechnic Baliwangi. You must install our AIS in your university, and your responsibility is to develop application for the fishermen. I think that's very fair cooperation between ITS and Polytechnic Banyuwangi, and a lot of things can be performed to support the fishermen obtaining cheap AIS, and at the same time we could support them to manage their safety during their operations. I think that's my response to Jedid. There are many questions about other things, Patrika. Do I need to respond now or later?
So later, because there is another question.
Okay, then.
There is a session 1 and 2. Thank you, Prof. Ketut. So because there is a SP as well, it's possible to recognize fishing vessels, and also Ministry of Fisheries also already developed. We call the AIS Bakatobi, if I'm not mistaken, already for the monitoring as well. So there is another idea can be enhanced together. So the third questions from Yoga to Professor Serdar. In real case, it is difficult to differentiate whether the ship is still moving in every slow speed, very slow speed, or it's already stopped and did the anchorage job. So in my limited knowledge after watching your presentation, is there any research that explains the range of the ship speed, especially low speed? Because it is relation to the risk, collision risk between the category whether in low risk and medium risk. So probably Professor Serdar is possible to answer. Professor Serdar, please.
Thank you very much. I want to say that the risk, collision risk, as you mentioned, is continue, anchorage or stop or drifting will continue. I don't know the other research, but for our research, our algorithm, our model will consist of focused on the ship speeds. So it's if the ship is stopped, is also getting there as a target, and calculation will continue at the dynamic base. For the further, if you want to, what is the range of the ship speeds, and if you want to see the data, please send me email. Then I can send some detailed information about the other research, because especially my colleague, Dr. Yunus Emre, has got this literature, and our data is collected on his computer. So if you want to detail information, please send the email I can give. But finally, I can say that, yes, we are considered, because as you mentioned, there is a continuous risk for the collision for stop or drifting vessels. Thank you.
Okay, for Pak Yoga, you can email as well to procedure in the case it's not clear enough for the answer. So we are starting to the session 2. There is from Fadila, from the Kyushu University, also to procedure. No? Fadila. Yeah. So from the Fadila, how is it going to make any difference if we are going to calculate, let's say, the TCPA or TCPA when the calculation is based on the center of ship? In fact, the AIS transponder is not located exactly in the center of the ship. So this is the question that probably the point is how can you calculate the TCPA or TCPA? Because the reason is the location of the AIS transponder it's not in the center of the ship. Could you answer the question, Professor? Please.
Yes, you are right. We text our calculation points for the own ships. We use the dimensions, and we just get the center for the ice location for the target ship. So it's mean that the nearest distance starting from the near distance to the 10 meters on the sides of the ships is calculated. So the minimum time or the minimum distance can get the input of the data for the algorithm. It will be enough.
Yeah, probably is the question is because the location of the AIS is not real in the center. How could you make some assumption whether the location in the center or in the aft or in the fore? In your calculation, how you make such kind of the assumption location of the AIS?
If you look smooth, can I show my? Sorry, just one. I want to show you the slide. The dimension of the vessel. I want to show the slide of that. As you see, for these ships, we get the antenna because we know the location of the antenna for the IS.
I see.
So the calculations for the own ships will be the points, all the 10 meters according to that, like a domain. But for the target ships, the IS locations and the point will already indicated. So for the own ships, the calculation will be according to these points. Sorry. Is it clear now?
Yeah. I mean that. So the location in all body of the ship, right? Your assumption.
Yes, exactly.
Okay. So yeah. So that is the point. So there is also some question. It's already raised hand. Let me check. The first question is from Gartinia Nurkolis. So could you give a question, please? Yeah, you can make a question. Bu Gartinia or Pak Gartinia? So, I'm not clear. Okay, Gartinia, please, you can make some question. I suppose one question is enough because time is very limited.
Pak Nurkalis mentioned that he cannot unmute the
Yes.
microphone.
Okay. Could you unmute? Saya bukan host soalnya. Pak Nur, nggak bisa ya? Saya nggak bisa unmute. Bisa. Ini masih mute, ini masih mute. Pak Nurkolis, could you unmute? So probably in the next questions. So Bu Nanditya Wardana or Pak Nandia Nandana, could you give a questions?
Pak Trika,
Okay.
one
Ya, Pak.
attendant mentioned that there is no facility to speak for the audience. I think we need to answer the.
Yeah.
Good
Bu
morning.
Nandia is already unmute, I suppose. So can you?
Yes, sir. Very good morning for all of the audience.
Okay, thank you, Pak Nandia.
Thank you for moderators for inviting us. I work for the Director General of Sea Transportation and Ministry of Transportations, and I will directly give the questions into Prof. Adi and Prof. Sedar. I have questions related to the presentation from both speakers on the usage of the Fuzzy Logic or similar assessment tools of software to assist the operation of VTS, and also related to the MEET technology to calculate the emissions. I have seen the similar initiatives being developed by other developers through their e-navigation projects, such as Fujitsu and others. Is there any difference? And does the system needs additional software? And in related with the VTS operations, since the various systems already installed, how could you integrate the software with the already installed systems? That's the first question. And the second question is for Pak Ketut. Thank you, Pak Ketut, for giving us the clear pictures of the IS condition in Indonesia. I agree with the challenges that might be raised in the future, but we rather focus on specific areas with high traffic density to be installed with IIS, especially ASB stations, and we will fully utilize the satellite for the surveillance. And we agree with the needs to have capacity building related with the human resources and the needs of the reliable yet cheaper devices. And we will welcome and encourage ITS to help us to overcome the challenges to enhance the safety of navigation and marine environmental protection in Indonesian waters. That's it for me, Mr. Moderator. Thank you very much.
Okay, Pak Nandia. So the first question, to whom you will give a direction?
I will give my first question to Prof. Adi and Prof. Heder because it's quite similar. It's related with the Fuzzy logic and similar assessment tools. Thank you, sir.
Okay, so Prof. Sedar or Prof. Adi, probably Prof. Adi first regarding the Fuzzy logic. Could you answer the question from the first question? And the second one, that does the system need to add additional software for the Fuzzy logic? And third one, could you integrate the system with the existing system? Probably Prof. Adi first, possible to answer, please, Prof. Adi.
If I can understand the question, it's something to do with linking with VTS, right? Because I know VTS also can be used to track vessel. AIS also tracking of vessel. So you have two data you can use. For our research, not easy to access the VTS data. Usually it is either done by some our marine department, and this data can be confidential. So it's not easy sometimes. You have to make some collaboration with them to get the VTS data. And another thing is that they are operators. You know, all they do is just collect the data. And if you ask them how you want to ask them to see the data, they also sometimes give you a blank face.
Probably the direct question is it possible that the fuzzy logic is implemented and your system calculating using fuzzy logic is possible to be integrated to the existing system or existing software? Is it possible? Because fuzzy logic is methodology, right, for assessing the risk.
Yes. We use fuzzy logic. I still can not clear. What do you mean by we are using fuzzy logic with AI's data
for risk assessment, right? Yeah, Bu Panandia, could you make clear the questions regarding the keynote speaker?
Thank you, Mr. Moderator. So to Professor Adi, so my questions is actually how the physiologic can be integrated into VTS systems, because on the VTS we need to decide or giving advice based on the situations in the on the waters. So in fact, with the using of physiologic, we can advise them in case there's some kind of a risk of collision or something like that. So what I'm saying is it possible to integrate the physiologic into the VTS systems, and do we need to install another software to make it happen or something like that? Thank you, Mr. Adi and Mr. Moderator.
Yes. VTS system means that they use AIS, or the one they use the radar as well?
Actually, the main tools will be IIS data and will be assessed by radar. Thank you, sir.
So if you have a VTS system, you collect AIS data. The next thing is to make the program yourself, or get somebody to make the program how you can use this data, and then use fuzzy logic to see whether there is risk or not. So I don't see it's impossible. It's the same like you have AIS data anywhere. If you have access to AIS data, you can do the fuzzy logic. What do you call it? Fuzzy logic estimation for risk. But the things that usually, if you have people who use VTS are just operator. That's what I understand. They don't do R&D. And also, I'm saying that people who operate, they always regard the data that they collect as security data, and they won't easily give it to you. I don't know, maybe in Turkey or Indonesia, you can easily get the data. For us, if you want to enter the place where they collect the data, you have to have special permission from the, I think, government or something. So we've already from our experience then a bit difficult to make the collaboration. Another thing, they don't do R&D. Also very hard to collaborate people who don't do R&D. So they may not be interested as well, unless there is some instruction that the BTS must incorporate fuzzy logic. Then they will look for people who can supply this software. But it's not possible. It's not impossible to do. Just it can be done. Only thing, you have to get the data out and then use fuzzy logic to process the data to estimate the risk. Is that okay for the answer?
Yeah, probably
Professor Seda
can. Probably Professor there can add something regarding the questions.
Yeah,
Professor Seda, please.
Yeah, I want to add something. Let's start from the last part. In Turkey, there is no public domain for websites to show the IS data, as Professor Adi mentioned, is prohibited. Just the researcher apply the maritime administration and asking the data format, and then they can receive, but they can use it for the research. For the application of the fuzzy logic algorithm or such algorithms or model for the VTS system, if you have any IS data, you can apply to everyone. But please consider that for a one VTS system, if we are talking very small size, we talk about the $1 million. So no one can give the allow to inside your system. So for example, our proposed model, how we offer our administration, or how we can offer. We can offer additional part, not inside of the system. They have existing VTS. Okay, the IS data will input the VTS system. Okay, one IS input will become our system and our model, and another screen or just the output will show on their screen. That's it. The other, you cannot enter these systems. Thank you very much.
Oke, Pak Abdul Aziz mau nyambung? Ya, probably mungkin pertanyaan juga. Yang to Prof Ketut, I suppose that because time is very limited, from Pak Nanditya. So is it possible to overcome the problem actually in marine traffic and so on, right? If I'm not mistaken, the question from the Pak Nandia. And the second one, Prof Ketut, the last question from PT PGN LNG Indonesia, Pak Fajar Kurniawan. AIS ITS can support about monitoring of fuel on real time. Is it implemented already? And any feedback from customer about the strength of AIS fuel monitoring, percents of benefit than before use AIS ITS on their fleet? So basically, the question is, the point is the fuel monitoring real time is already implemented or not yet? Professor.
Thank you, Pak Tri.
Yeah, please.
Allow me to respond one by one. The first from colleague from Directorate General of Sea Transportation. Thank you very much for the questions. We focus on the implementation of AIS rather than the satellite because, as you may know, that the data we obtain from satellite is very much difficult to be used as a real-time information. There is a delay of obtaining the data. In other position, we need to have a real-time application. So that the reason the AIS is more applicable in that sense. And then we also appreciate the Directorate General of Sea Transportation for providing opportunity of us participating in the study in the effort of implementing the two main streets in Indonesia, Sunda Strait and Lombok Strait, as the strait implement the traffic separation scheme. I respond to question from Pak Fajar, our colleague in PT Perusahaan Gas Negara PGN. Pak Fajar, the fuel monitoring is a prototype. We developed the quite many algorithms in using AIS as a fuel monitoring system for vessels. The problem is the reason we developed this application because in some cases monitoring fuel consumption in ships is rather tricky. In some situations, the seafarers deliberately, distract the sensors. Then we cannot control the fuel monitoring in that sense. So what we do in ITS is using some empirical formula to calculate the fuel consumption based on the ship the main engine informations we get from shipping database, and then we can compare this information with the sensor-based monitoring system. So it's the idea. Responding to Pak Freddy from BKI, we, as been mentioned by Prof. Serdar, we not open the web based AIS because it contains very important information. For example, if hijackers or pirates have that information, that they will very much easily to hijack the vessels. So we can only provide those data to responsible parties. Can we monitor in shallow water using ICE-ITS or pipeline? Yes, we can, because we are not we are not implementing sensor on the pipeline. No, in fact, we only locate the coordinate of the pipeline and we compare with the coordinate of the vessels. So those are the way we measure the distance between the vessels and the pipeline. And according to our experience, we also implement artificial intelligence in measuring whether the one vessel is moving or stop. Because even though one vessel is stopped or doing anchorage, still the vessel is moving because of the environment. So we need to make sure exactly whether one vessel is decided to be in a stop position or in moving conditions.
Yeah.
If we consider only using the AIS data, then sometimes we mispredict, because actually the vessel is stopped, but because of the change of the coordinate, we consider the vessel is moving. So artificial intelligence is one of the solution to make sure one vessel is moving or one vessel is in stop condition. I think that's all my response, Patrika. Thank you.
Okay, thank you, Prof. Ketut. Because its time is very limited, I know that there are so many questions, and also that there is so many questions it's not yet answered, are not answered by the keynote speaker, because we have to move to a next agenda. First of all, giving applause to three prominent keynote speakers, because I suppose that we have a new insight, the direction, that new idea to make a research, possibility research by utilizing the AI data. Let me summarize several possibility research have been conducted, like the risk assessment, then emission monitoring, then fuel monitoring, and so on. And we believe that the AIS data is possible to make new insight as well for the next direction for the research. So the next agenda then, for the appreciation for the three keynote speakers, then I would like to hand over the certificate of recognition first to the Professor Dr. Serdar Gum as the keynote speaker in second Maritime Safety International Conference MASTIC 2020. And the second keynote speaker, we also would like to hand over to Professor Dr. Adi Maimun as the keynote speaker, the second keynote speaker in the second MASTIC 2020. And the last one, we also hand over the certificate recognition to Professor Dr. Ketut Kuda Artana as the third keynote speaker, MASTIC 2020. I believe that all of what already describing and explaining by three keynote speakers is very beneficial for us. And I suppose that this is the last, the last presentation for three keynote speakers. Then I would like to deliver again, to return back to the master of ceremony. To master of the ceremony, please.
Well, thank you very much for the moderator and all of the keynote speaker for such outstanding research and presentation, and for all the attendees for the discussion. Moving on, ladies and gentlemen, we will going to our next agenda. But before that, we entering our break. Before we entering parallel session, there is a 15-minute for break. And after 15 minutes of break, there is 5 classes, different classes in parallel session. Parallel session A is a marine risk assessment. Parallel session B is a marine safety. Parallel session C is a design and experimental study in maritime research. Parallel session D is shipping and maritime management. And parallel session E is marine environmental protection and energy efficient. So in this part of agenda, after 15 minutes, we have a break. Make sure that all of you entering into the parallel sessions depends on which parallel sessions you are. That's all for me. See you in 15 minutes later. And don't forget, after we entering parallel sessions, don't forget to come back into this link because we're gonna have a closing ceremony and we're gonna announce who is the best paper and best presenter. Thank you very much.
Thank you very much.
Thank you very much, Prof. Adi, Prof. Serdar.
Prof. Serdar, Pak Aziz, matur nuwun.
Waktu pertama kali kulihat dirimu hadir, rasa hati ini inginkan dirimu. Hati tenang mendengar suara indah menyapa, geloranya hati ini tak kusangka. Rasa ini tak tertahan, hati ini selalu untukmu. Terimalah lagu ini dari orang biasa, tapi cintaku padamu luar biasa. Aku tak punya bunga, aku tak punya harta, yang ku punya hanyalah hati yang setia, tulus padamu. Hari-hari berganti, kini cinta pun hadir. Melihatmu, memandangmu bagai bidadari. Lentik indah matamu, manis senyum bibirmu, hitam panjang rambutmu, anggun terikat. Rasa ini tak tertahan, hati ini selalu untukmu. Terimalah lagu ini dari orang biasa, tapi cintaku padamu luar biasa. Aku tak punya bunga, aku tak punya harta, yang ku punya hanyalah hati yang setia, tulus padamu. tulus padamu.